Today I will be talking about the Finkelstein reaction. This reaction involves the exchange of one halogen atom in an alkyl halide for another halogen atom using a metal halide salt. This mechanism for this reaction is a simple single-step nucleophilic substitution reaction, which is also known as an SN2 mechanism. In this example, X tends to be bromine or chlorine, and Y tends to be iodine. For this example, Y, which is iodine, is negatively charged. This will attack the R group, and the bond connecting the R group with the X group, which tends to be bromine or chlorine, will then go to X, and then X will attack the positive charged sodium. The products will then be these, and you can tell that the Y and X got exchanged. For the reaction coordinate diagram, to build it, you have to look at the relative energy. So that means you have to look at the bonds broken and the bonds formed. Once you calculate the total amount of bonds broken and the total amount of bonds formed, you then subtract the bonds broken to the bonds formed. And I yielded a negative number, which means that my coordinate diagram for this reaction will be exergonic. Because it is exergonic, the starting material will have a higher amount of energy than the products. So right here, this is the starting materials, this is the transition state, and then this is the products. To answer the following two questions, how might you speed up the reaction? Since the Finkelstein reaction is an SN2 mechanism, if the concentration of alkyl group or the nucleophile is increased, the rate of the reaction will also increase. For example, in this picture, if the concentration of iodine, the nucleophile, was increased, the reaction would speed up. The second question was, what would you predict the delta G and K for this reaction to be? The delta G for this Finkelstein reaction can be predicted as spontaneous because looking at the reaction coordinate diagram, we can tell that the starting material is higher in energy than the products, making it exergonic. After finding the delta G is negative and exergonic, it can be predicted that the equilibrium constant, K, is positive and greater than 1. So this delta G will be negative. So that predicts that it will be spontaneous. So the next question is, find an example of a recent use of this reaction in literature. So I found a article, and it titled was a benchmark study of kinetic isotope effects and barrier heights for the Finkelstein reaction. So in this literature, Finkelstein reaction was used to study the effects of bromine and bulk carbon kinetic isotope effects and the reaction barrier heights between two bromoethyl benzene and the iodine ion with a solvent, either acetone or acetone trial. Performance of multi-density functional theory was used, and the Finkelstein reaction was used in its condensed phase where bromide was substituted by iodine while in the presence of a solvent. So here is the mechanism that they use for this article and study. You can see the bromine got switched out in exchange with the iodine. So this is my project about the Finkelstein reaction, and I hope you enjoyed it.